Welcome, everyone. Thank you for joining. My name is Robert Munteanu, and I'm here to talk about whether or when do you want to go fully micro, obviously fully microservices. Wrong button. I'm new with this. So a couple of words about myself. I work with Adobe. Yes, we do some other things besides the stuff that you know about us. I work on something called Adobe Experience Manager. Long story short, we build on a lot of cool open source projects. And I will be showing those today when talking about the experience of going or not fully micro. So the title of the talk is a bit vague. I know I'm not great at titles or at cache invalidation. I'll just have you know that the other proposal was 50 Shades of Micro. I decided it was a bad idea for many, many reasons. But anyway, just to give you a little more solid foundation about what we're going to be talking about today, first of all, microservices versus monoliths. Then I arrived at the conclusion that microservices, or rather microservice implementation approaches, are not the same, are not equal. So we're going to talk a bit about how we implement microservices. Then we're going to try to find the middle ground using a gateway approach, a microservice gateway approach. And since that gateway will be built as a proof of concept using Apache Sling, I will give you the world's shortest introduction to Apache Sling, and then see how things look in practice. Okay, let's talk a bit about microservices and monoliths. In life, you have decisions, right? You have make business decisions, personal decisions, business decisions, and there are two kinds of reasons for taking those decisions: real reasons and declared reasons. Sometimes they match, sometimes they don't. Right, so when the technology team comes and says, we really need to rebuild that application in Node.js because it's an asynchronous framework and it plays better, blah, blah, blah. What they're really saying is, I saw it on Hacker News and I really have to build an application with it. Microservices are very high on the fashionable scale, right? Everybody's talking about it. No, I'm talking about them. Many other people are talking about them. Lots of cool companies are using them. So there's a high pressure to use microservices. It's unfortunately, one of the big reasons for using microservices, but not necessarily the right one. Now, the biggest, let's say, technological reason is that microservices allow you to decouple implementation from what you actually consume. So to give you an example, if you're consuming HTTP, a JSON payload over HTTP, you don't really care what's behind there, right? It can be something, it can be Ruby on Rails, it can be Scala, it can be something written in Java with drop wizard or what have you. You don't really care. So in turn, that means that your technical teams can choose the tool that suits them best. For instance, you have a large organization that spans 3 continents. You have multiple technology, let's call them silos or excellence centers that have different technology backgrounds due to acquisitions, due to how the local technology market is. Before that, if they would be building one single application, you would have to have the single runtime stack, and then everybody would have to do Java, let's say. Now, if you have some teams which are better at different technologies, you can have them do their microservices in Python or Node.js. So they really do what they know best, which is one of the great technical advantages of microservices. Then you get a bit into process advantages, which is when doing microservices, you always have this problem that things can fail. Things can go away. You rely on a billing microservice, which is on a different server in a different process, and it can go away without letting you know. So that logic that you used to apply to databases, careful pooling, monitoring, sizing, and all that, suddenly needs to apply to microservices as well, right? To whole other parts of your application. And while that can be viewed as an obstacle, it actually makes your application much more resilient. So in my book, that's a plus. Scaling. Now, if you have this big monolithic application, you probably have two big components, right? A web application and a database server. And when you want to scale one of them, if you're already at the scale problem, you're probably using big servers, right? And those cost money. If you're going to from 3 big database servers to 4 big database servers, that's going to be a bit costly. But in our example, we have 2 microservices, order processing and catalog search. And we decided that for some reason, catalog search takes more processing time. So it's easy to scale up just these instances, or even remove from the load balancer. Let's say we have 4 here, we take 2 from load order processing, we add 2 to catalog search. And we have a simpler story about balancing because typically these machines are smaller. A level of reusability is another interesting point with microservices. So microservices are established around the idea of reusing business level functionality. So you will not have a left pad microservice, right? Or maybe, let's hope not. Let's hope you don't have a left pad microservice. So you can have microservices which do, let's say, a geolocation microservice, which is the go-to point in your application for doing geolocation. So that allows you at the business or the organization level to do a better use. Deployment is more or less tied to the scaling idea. You have smaller units. So you don't have to stop the world. You don't have to stop your application while you redeploy or restart a sort of large monolithic application that takes a long time because it does so many things. Microservices will be small, isolated, and ideally start fast. And that's where you get to this example. If you want to do a deployment of the order processing, you just have to redeploy 2 instances, or if you're doing something more courageous, you add 2 instances and you take 2 away. And if those go quickly enough, that should be really, really fast for you. And now we're getting to the more management-oriented benefits. How do you do faster delivery? Which is something I don't think anyone is happy to deliver every 3 months or 6 months or a year. Mostly what I've seen done is getting some sort of iterative process like Scrum on the table, and then teams deliver every 2, 3, 4 weeks. And the question is, what ways do we have to get delivery done faster? Rather not deliver more, not deliver the same in a smaller time frame, but deliver more often. Instead of delivering, let's say, 10 issues in 4 weeks, let's deliver 2 or 3 every 1 week. And here's a hypothetical example of team which releases every 4 weeks, so week 1, week 4, week 7, or 3 weeks rather. And they didn't find the proper way of reducing this velocity. So what they can do is split the deliverable, right? So instead of doing one big monolithic application, you get to do microservices. So each microservice has its own life cycle, its own delivery. So you can see that the catalog team was actually the one that was doing the releases every 3 weeks, while other teams were able to deploy much more often. So by going to the route of microservices, you actually get to deliver faster. Not more, but faster. You get the changes to your clients much faster, which is good. That is not to say I'm an unconditional fan of microservices. There are voices, including this guy, that say, well, it's not all good with microservices. So the bottom line here is that if your code base wasn't great to start with, using microservices is not going to solve that issue, right? There's another very more graphical image with big poop and small poop, but I decided not to show that. You can probably find it on Twitter. So. But really, why would we want to use monoliths instead of microservices? Now, these are, that's pretty small, I think. These are some of the things which get better with age, just like wine. So these would be 8 fallacies of distributed computing that were coined sometimes in 1984, rather, so 20-something years ago. So they are just as relevant today as they were at that time, the time they were thought of. I think 2 or 3 weeks ago, we had the largest distributed denial of service attack in history, something about 10 million IPs. So it's the Internet of Things gone right or wrong, depends how you look at it. But my point is that we're using the network much, much more intensively than we used to. So microservices only serve to amplify this effect. Before, you had a single application running in a virtual machine or in a single process space. Anyway, I haven't seen the JVM drop a method call in my professional experience, but the network, So this distributed nature of microservices, which is one of the greatest strengths, is also something we should really should really look attentively at. So one thing I want to discuss is latency, right? Speed is infinite, latency is 0. When you start to do microservices, so not just 2, 3, 5 microservices, when you really start to do microservices, then you get to the point where you have lots of microservices interdependencies. For instance, you have a foundational microservice like geolocation. And the billing module wants to know which country or in which state the user is in so they can calculate shipping and taxes. User management maybe wants to know for customer support which country the user is located in, and so on and so forth. So what you get is this very complex network of microservice calls which can quickly saturate your network. And the latency increases, the throughput decreases, and it's something that you just have to deal with. Of course, there are ways to get around it, for instance, caching, right? Or just delocalizing data, pushing the data from the microservice out to the other microservices. But again, it's a cost that you must take. If you want to do microservices and you want to do them big scale, you have to take these things into account. Now, security. Now, this is a typical computer hacker. Notice the gloves. They give you extra skill when typing. Now, security with microservices is still a pretty young field. We started understanding pretty well how to secure monoliths, or let's say public-facing applications, but securing the network, because microservices typically run inside the firewall, right? They're not accessible from the outside. But there are issues such as how do we get microservices to trust each other? How do we pass authentication credentials from a monolith to microservices? Does each microservice authenticate against a central identity provider? Do we have a central entry point for that which is done somewhere else? So we don't yet have very good answers to these kinds of questions. There are some mechanisms, and I will talk a bit later when discussing the API Gateway. But you need to ensure two things. One, authentication. Right, so the user credentials, how do you transport the user credentials? And two, confidentiality, and integrity. How do you ensure that a message that goes between microservices hasn't been tampered with? And typically, one answer is private networks. You just isolate microservices in their own private network and say, hey, nothing else can get in, therefore I'm secure. That's one possible approach. Another approach is doing SSL everywhere. But then you have to ask yourself, well, my very small and agile microservices deployment strategy just has a step which says, contact SSL certificate vendor, request a new certificate, obtain approval for purchasing, wait for 1 day until it's granted to me, or set up your own infrastructure for code signing and for rather code certificates and all that, which again is doable, but you need to take this into account when going to microservices. Now, about operations, let's consider that we have this sort of typical monolith where we have application server, database server, and a NoSQL cache. Now, those are 3 components that are in the mix, and your operation team can probably take 3 components and understand how to monitor them, how to tune them, how to take care when something goes wrong. But on the other hand, if you go get complete freedom and say, well, we have 1, 2, 3, 4 runtimes and 1, 2, 3, 4 persistent technologies, that's an increase that, again, your operations team must, they will take the hit for this. And it's not something that comes for free. So again, monoliths are easier to operate. I know I said that microservices have the advantage of getting code reuse, but they also have the disadvantage of not getting code reuse. And what do I mean by that? It's the idea that microservices are supposed to be extremely self-contained, and one team is supposed to completely own them without interference from others. So while you get to reuse at the let's say business level functionality, when you're doing let's say small level sort of library code reuse, you need to ask yourself what do you want more? Do you want to allow teams to completely own the code, or do you want to have some sort of shared code which is used by more microservices, but at the same time you introduce these hidden dependencies between microservices because some teams must wait on other teams, which are sort of against the spirit of, let's say, properly done microservices. Now, some of you might be familiar with Monty Python, but briefly, this is King Arthur, and this is the Black Knight. And the Black Knight, opposed King Arthur, and he ended up losing 2 hands and 1 leg. But he still says, "It's nothing but a flesh wound. I'm here. Come back and fight, you coward." And I think this is sort of like a web application which has most of its microservices down, but some are still up. Now, search isn't working, we can't place any orders, and you can't really browse, but you really have the user account page which is up, so 200, okay, all things check out. Joke aside, when asking yourself, is my website up or is my application up, is a very simple question to ask with a monolith. It's either up or it's not. But with microservices, you need to find out for yourself, what does that mean? What does that mean that my website is up? What are the services behind it that must be up for it to be, as a system, considered up? And when talking about services, you need to find out where those services are, right? So if you have 20 microservices, you can't just hard code a list of IPs or host names in your configuration file and say, okay, that's how I find my services. Because you probably want to scale them out. You want different setups for production, for testing, for development. So you need another piece that you will add to your infrastructure for service discovery, which is doable. It's not rocket science. Many people are doing it. But again, another cost in time and in maintenance that you don't have with monoliths. And also, one of the fun things is correlating something, a request between microservices when something goes wrong. So, right, you have this request to your web application, and then you send off 5 requests to microservices, and something goes wrong into one of them, and you want to correlate all requests and find out what happened. Good luck. It's something that you need, again, to build into your infrastructure. Have a centralized location for logging, and then have some sort of means of correlating requests between microservices, so a unique identifier, and then making sure the clocks are in sync, which is a trivial problem, as we all know, and then make them ordered by something reasonable like timestamps or user IDs. Okay, I've done enough bashing on microservices. Now, why do I say that not all microservices are equal, or that not all implementation strategies are equal? Well, you can have two large implementation classes. The first one is what I call the unbounded implementation strategy, where you give the development teams complete freedom. Right? So you want to do a microservice, I don't care what is that in. Don't tell me, I don't want to know. You handle this with the ops teams. You write in whatever you're good at. So that gives maximum technical freedom to do what they want best. On the other hand, you have this bounded sort of limited microservices implementation approach where you have one runtime platform, whether it's Spring Boot, Drop Wizard, or whatever you think suits you best. And this time you have something that is mandated throughout the organization. And why would you do that? Well, the question is, what do you want to do with microservices? Do you want to get the technical benefits, complete freedom? Do you want to get the organizational and delivery benefits, like much faster delivery pace? Then you already start understanding in which direction you want to go to. The point is, microservices are not an all or nothing approach. There are gradual approaches to microservices. And one of these is the middle ground. And that's using something I called, it's called an API gateway. An API gateway is basically another layer which sits between your microservices, communicating amongst each other, or your between your client application and your microservices. And it can isolate a number of cross-cutting concerns, authentication, some parts of authorization. It's a very good place to gather key performance indicators. Since all requests go through such a gateway, it very well knows the number of requests per second. It knows which services are slow. And it can do something which is called circuit breaking, which means if a part of a system is down, you stop sending requests to it because you know they're going to fail. Maybe try a little bit later, see if it goes up. Or even worse, if it's not down, if it's down, well, at least we get an error immediately. If it's slow, now that's something which is a catastrophe because it can break your application down if a component is slow. So an API gateway is an ideal place to centralize this logic. Now, ideally, it's stateless because you want to scale this out. These will be in the middle of your infrastructure. It should be very lightweight, again, because you want to have lots of these. And it should be extensible because you don't want to hold back the microservice development just because the gateway isn't extensible enough to support the new developments that you want. Now, how would this look? So something which I call a transparent gateway, which means it doesn't modify the payload that gets sent between the consumer and the microservice. So a consumer, let's say, makes a put request to payments. It goes to the API gateway. The API gateway sends almost the exact same request. Maybe it does those authentication, maybe adds some headers, and then sends it on the way to the microservice. The microservice returns created response. Everything is fine in JSON, and then the API gateway sends it back to the consumer. The advantage of such a setup is that you don't have to do special code for the gateway. It speaks the same protocol as the microservice, so you can transparently introduce it into your whole operation if you choose to do so. It's probably just a configuration change, right? Point to a new location. So this, if you have an existing microservices infrastructure and you want to centralize some of the cross-cutting concerns, this sort of transparent gateway is a good first start. Now, there has to be another, otherwise I wouldn't have given that a name. So something which I called a transforming gateway as opposed to a non-transforming gateway can offer questions to a couple of can offer answers rather to a couple of hard questions. First of all is how do we do versioning with microservices, which is something which everyone loves to debate. Let's say we have a microservice which wants to move to version 2 because they decided that version 1 is crappy and something they should never have written. Right, then what do the consumers do? Some of the consumers won't be ready. So you have multiple options. One, you make the microservice implement 2 versions, which is not so nice because microservices are supposed to be small, isolated, agile, blah, 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 not deal with multiple versions. Or you make the consumer aware of multiple versions, which again isn't all that nice. Or you make this guy, right? The API gateway able to adapt to multiple versions. So the consumer can move to the new version whenever it's ready. The microservice can move to a new version whenever, and everybody's happy. If you're doing multiple protocols, right? So some are doing JSON, some are doing XML, protocol buffers. There's many, many choices. What do you do as a consumer? Do you want to really know all of those formats and talk to them, or you can have the API gateway as an adapter which transforms and you say, hey, I just want to consume JSON, and the gateway can give you that. And also, if you're talking to many microservices, the network calls, at least when still not moving to HTTP2, you have many network calls, they will add latency, and the gateway can do batching as well. Okay, this is what my diagram skills are not that good. Let's say the consumer calls the API gateway with special offers request, then the API gateway sends requests to multiple microservices, and then someone returns XML, someone returns JSON, and then the gateway transforms the response into one single payload and sends it back to consumer as JSON. Whew, I'm running a bit late. So Apache Sling, obviously an Apache project. It's been 10 years in the making. mostly Java, and I won't tell you how much Maven we do, but it's a lot. We have a good history of activity increasing, and as an API gateway, it's a good proposition. First of all, it's content-oriented or RESTful, which means that we are already able to serve resources in a RESTful way by design. We offer a hierarchical view of our repository. We don't do SQL or NoSQL as a persistence layer. It's a low-level detail, but we are offered to expose everything as in a RESTful format by default, and I'll show you immediately what that means. Very lightweight. It's extensible. Internally uses OSGi, so you can. It has many extension points, which means that you are free to extend it however you see, and it's very easy to deploy in terms. It's a runnable jar, and nothing could be simpler than Java. I mean, all Docker is simpler than running a jar, according to some people. But anyway, for me, it's very simple to start and deploy. And this is the RESTful part that I was talking about. So when doing telling you what do I have in my repository, it doesn't have a concept of tables or sets or whatever. It's just a tree of resources, which is ideally mapped to a URL space. So RESTful, so very good for microservices. And the way this gateway looks is in the front, we have authentication, authorization, and then we have various subtrees in the URL space, which are mapped by Apache Sling to various microservices. And in between, we have all of these cross-cutting concerns that happen before authentication and authorization. The demo application is Microservices Gateway, which runs a number of proxies, goes to social microservices, which return Twitter messages, spam checking, and a list of articles. So it's basically a blog. Sling does this, receives the authentication data, does its own authentication, then encodes it and sends it to the microservices, which are able to decode and verify it. We've done this using JSON Web Tokens, which is basically an internet standards which packs a string representation of a header, which says, hey, I'm doing JSON Web Tokens using this encoding algorithm. This is the data. These are my claims. This is John Doe, and he's an admin. And then a signature. Important to see here that you don't have the, it's not encrypted, so it's not confidentiality is not ensured. You need to check the signature to see that the message is indeed not been tampered with. Okay, I have 2 minutes left for the demo. That's going to make it very fun. Let's see. Right, so we have here, we have 3 microservices running Drop Wizard and Spring Boot. We have the Sling, we call it the Launchpad, which is basically the assembly, all the artifacts that go into your application. I'm going to skip straight to the demo. So whatever happens on port 8080 is this visible? Let's make it a bit larger. On port 8080 is going through the gateway. Now, first of all, I get a forbidden code because I went to a microservice without any authentication data. So let's just add authentication. Oh, that was the incorrect password. Later step. So if I add the authentication, you can see here that the request has been successfully served, and everything was passed through the gateway. Of course, if I do an incorrect authentication, the gateway says, okay, I don't know who you are with that password, and no request has went to the microservice. Now, something which has been transformed as we have another microservice which returns a list of Twitter messages. But still, we would like to have them returned in a JSON format by the gateway. So the Sling is able to do that for us. And the way we do this is we have this sort of abstraction which says, hey, we can map any resource that you want to give us, whether it's something on file, it's a relational database, it's something else as a resource. And this is the resource resolver that I use, which says, hey, at this path, you will mount those resources, right? So it's a single entry. You get the remote URL, you parse the messages, and you construct a resource out of it. I will skip the rest since I'm running very short on time. So, conclusion. You saw very little of it, but Apache Sling is very cool and featureful web application development framework. It was actually built before microservices were designed as we know of them today. But since it's very extensible and RESTful, it's a very good fit to build such a gateway. Microservices are not an all-out proposition, right? You can choose various levels of, let's say, investment in microservices, and you need to find out for yourself, for your organization, for your team, which is the best level of involvement. And I try to be subtle with this. Okay, try Apache Sling today. It's a very cool piece of technology. I have some resources. I don't have time for questions, but I'll be here all week. And please don't forget to rate the talk in the app. Thank you very much. Okay.